Hello everyone, welcome to the third video class in searching algorithms. And in this opportunity, we're going to be talking about the binary search. So the binary search part is going to be split into two. So we're going to have a third and a fourth video. So in this first one, we're going to talk about the theory behind it. It's a little bit more complex than the linear search. And then in the second part, we're going to do the proper coding implementation. So let's start with the binary search theory. Now, the binary search is a different searching algorithm. Now, it makes sense. The linear search makes sense because you know that if you're looking for a particular element, you won't know if the element's in there until you have checked each one of them. However, the binary search offers a more efficient way to do this search as long as the elements are sorted. That means that whatever number of elements I have in there, if they are sorted, whether it is in an ascending or descending way, then I can know if the elements in there in less iterations than the binary search that the linear search would take. Now, this is an important thing that you need to keep in mind. For the binary search to work, the collection that I'm searching has to be sorted. If it's not sorted, then the binary search is not reliable. The binary search doesn't work. So assuming that whatever collection we're getting is actually sorted, then we can do an algorithm that is way more efficient than what the linear search would be. Okay, so how does this work? So instead of searching from one to one from the beginning, to the end, what we're going to do is I'm going to search for my element in the middle of the collection. The element that I'm looking for is equals to the element in the middle. That's it. I found it, so I can return that particular position. But if the element that I'm looking for is not the one at the middle, because the collection is sorted, then I can have a look and say, well, the element that I'm looking for is bigger or smaller. So if it's smaller, I can go to the uh, upper part of the collection. But if it's smaller, then I can go. If it's smaller, I can go to the lower part of the collection. But if it's bigger, then I can go to the upper part of the collection because the collection is sorted. So I don't need to search the whole collection because if I start in the middle, I can discard a completely half of the search. So absolutely the same as before, the binary search algorithm is going to return a particular position. Now, this could be modified if we need it, but for now, let's return an integer number, and then we'll return -1 if the element is not in there. Now, let's see how that's going to work from an example kind of view. So suppose I have this list. I'm looking for the number 8, and my list is 1, 2, 3, 4, 6, 7, 8, 9. Now I know my collection has to be sorted. So I'm going to start comparing my element in the middle. In this case, it could be 4 or 6. I just decided to be 4, but it could be either of them. So if 4 is not the element that I'm looking for, then I'm going to compare and I'm going to say, okay, what is the number that I'm looking for? So I'm looking for 8. So I know 8, for being bigger than 4, has to be in the upper section of the array, and it cannot be in the lower section of the array. So that means that I can just automatically discard all the lower part and not search for them because it cannot be there. So I can assume that if my element is in the array, it will be in the upper part of the array. So my next iteration is going to have two bounds. The upper bound is going to be the same as the one before, but now my lower bound is not going to be the start of the array. It's going to be the middle +1. So I'm going to limit my element to the upper section. Now, again, I'm going to check between this element and this element, between my lower bound and my upper bound. I'm going to check the one in the middle. Again, it could be 7 or 8, but I decided, just as before, I'm going with the one lower. So in this case, 7. So I know 7 is not 8. So I need to do a next iteration. So I have to go between 8 and 9. And the middle between 8 and 9, again, it would be 8 because it's the lower middle or the lower between the two of them. And I have found it. Now, interestingly, for a linear search algorithm, it would have taken 8 iterations to get here, while in the binary search, in only 3 iterations, the element was found. So we can say that the binary search is a lot smarter as long as the collection is sorted. So that's something that we need to keep in mind. Now, the next thing here would be, well, how do we code this? Now, because this coding is a little bit more, it's not particularly difficult, but it's a little bit more elaborate. So we're going to leave that for the next video. Thank you very much for watching, and I'll see you in the next one.